Hi guys, let me introduce you to Ben. Say hi to the camera, Ben. He's a bit shy. No, but it's finally gotten cold enough that we can light the fireplace. And I'm considering starting a new segment where we can have a sort of loose discussion about various topics. I know I haven't been posting a video in a while. I've been working on various projects over the summer, but I haven't really completed anything. Also, the channel's past 200 subscribers, at least that I don't know, and I honestly have to admit I'm a bit flattered. So, thanks you guys. But let's get on with today's topic. And this all started with two comments. One asked me to cover Einstein's field equations, and I started filming the video, but coincidentally, during filming I also got a comment on one of the other videos, the Yang-Mills video to be specific, stating that, well, this was clearly not intended for the general audience. And yeah, I definitely agree, but also I think that if you're looking for Yang-Mills on YouTube, you're not really part of the general audience. And I do agree that the video requires a certain background, but I also have a problem seeing how I'm supposed to cram at least a few years of study into a 20-minute video. And I could cop out and do what most YouTubers do and resort to the analogy. And physics is teeming with analogies. We have the electro-hydraulic analogy, we have the planetary model of the atom, we have I don't know what you call it, trampoline model of general relativity. You've probably seen it, where you have some sort of fabric, some kind of elastic fabric, and you put a bowling ball in the middle, and then you start throwing marbles, and the curvature induced by this bowling ball deflects the path of those marbles. But if you start asking questions like, well, why did the bowling ball curve the fabric? Well, because it was pulled down by gravity, the very thing we are trying to explain with the analogy. And further, we may say something like, well, the presence of energy and mass curves the fabric of space-time. But this curvature that we're referring to is not curvature in the colloquial context that we used to. For instance, let's see, if I have this sheet of paper, I think most of us would say that this thing is curved, but in the context of general relativity, this thing is absolutely flat. We will cover this in more detail when I post the video on Einstein's field equations, but hopefully you see the problem with an analogy. And don't get me wrong, I think they often serve a purpose as a mental scaffolding for the underlying concept. But way too often I see analogies acting as the catalyst for the Dunning-Kruger effect. For those not familiar, the Dunning-Kruger effect is the phenomenon when someone mistakenly assess their cognitive abilities as greater than they are, when in fact you are not really aware of how little you actually know. And we all go into this trap once in a while, me included. I call it the disease of the undergrad, but you will encounter it in all walks of life. But let's get back on track. I remember Richard Fineman in an interview called Fun to Imagine, where he's asked, it's a magnet, yeah, so he's asked what if you have two magnets and they will repel. And he don't really answers the question, other than that they do. And he sort of goes around the question and talks about electrostatics, but they're closely related. And he makes the point that we take for granted that when I put my finger on the chair, it doesn't go through. But when magnets do the same thing, we start asking why. Now, if I had two opposite charges, they would attract. And as Fineman says, I could cheat you and tell you it's like an invisible rubber band that's pulling them together. But then you might start asking about the nature of the band. Well, what is it that makes the rubber band go together? Well, it has opposite electric charges inside of it that pulls it back together again. And we have come full circle. And here we may see the fundamental problem of explaining physics to the layman. We are often talking about something that does not have an equivalent in the universe. These things will behave as they behave, and not like something else. You wouldn't say a kangaroo is like a bird because they both walk on two legs. Sharing properties does not constitute equivalence. And we could have talked about homomorphisms and endomorphisms, but those are just fancy words and I don't really think they would add to the discussion. Oh, you need to go take a shit. Run! 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 Yeah, you better go in the bin. Go in the bin. But I would like to ask you guys how you think I should go forward. Should I rely on analogies to explain unfamiliar concepts? Or should I go for the stripped down, straight to the point explanation that relies on you guys accepting an unfamiliar concept at face value? Or maybe there's a middle way where we take the analogy and then pick it apart, or maybe we should just go back to basics and make like a long video series where we go through everything in meticulous detail. Or does that go beyond the attention span of YouTube? I'm not sure. And then there's the fact that I'm not making any money with this, and I doubt I ever will. So, is it really worth my time? I'm not sure. I really do enjoy making videos for you guys, don't get me wrong. But hopefully you can see why I can't make it a priority. But, yeah, let me know what you think down in the comments. And thanks for watching. Keep it interesting.